Kia ora. Today we're looking at balancing chemical equations. This is a very important skill to have in chemistry, and you need to be able to balance a wide range of chemical equations. So all sorts of chemical reactions are all represented by chemical equations. They're used as a symbolic representation, and it's really a form of shorthand that chemists practice. Now, a chemical equation shows the reactants on the left-hand side of the equation, followed by an arrow pointing to the products that form. Notice it's an arrow in the middle of that equation, not an equal sign. So here we've got an example, and we've got methane gas reacting with oxygen gas to form carbon dioxide gas and water gas. Water vapour, but we'll call it water gas just to make it easier for ourselves today. In a chemical reaction, mass is conserved. So that means we have the same mass in grams on both sides of the equation. But the difference is, and what makes it a chemical reaction, is that atoms are rearranged to form new compounds, so new substances are formed. So in this example where we've got methane reacting with oxygen, our new products are carbon dioxide and water. But do notice that the type of each atom has the same number on both the left and the right hand side of the equation. So on the left the carbon is represented with a black ball, and same on the right, so there's one of each of carbons. Oxygen, the red, represented by the red, there are 4 oxygens, and if we count them up on the right, 1, 2, 3, 4 oxygens are present. Likewise with the hydrogens, being the white ones, there are 4 hydrogens on both sides of the equation. So we need to show the representation in letters. We don't normally draw diagrams. You can if you want for a start, but you need to be able to show this using letters. We've got 1 carbon and 4 hydrogens in methane, and it's a gas, so we put this symbol G in brackets. It is usual to include the states of each substance in brackets in an equation. It's not essential for level 2, but it is good practice to do so, so I would encourage you to put states in all of your balanced equations. And the methane reacts with, that plus means reacts with, oxygen gas. Okay, again we've got the G there for gas, forming carbon dioxide and water. Okay, both gases as well, so we've got CO2 plus H2O. Now you notice there are small numbers and large numbers in this equation. The small numbers say how many atoms are in that molecule. So here we've got 2 hydrogens and 1 oxygen. The big numbers say how many of those types of substance, how many of that type of substance is needed in the equation. Here we've got 2 waters forming, so we need to put a 2 in front to say there are 2 of them. We don't change that 2 in the middle to a 4 and then add a 2 after the oxygen, because that would imply a different shaped molecule. You notice here we've got 2 forms of H2O. So, for example, what if we are making water from hydrogen gas and oxygen gas? Now you see here H2, hydrogen, is represented by H2, oxygen represented by O2, because that's how hydrogen and oxygen exist as elements, forming H2O, water. If we look on the left, there are 2 hydrogens, and on the right there are 2 hydrogens, so hydrogen is balanced. But if we look at oxygen, there are 2 oxygens on the left, but only 1 on the right. So therefore the oxygens are not balanced. This is not a balanced equation. How can we balance those oxygens? Well, we can't just go and put a little 2 after the O in the water. We have to put a 2 in front. So let's do that. Put a 2 in front of the water. Now on this side, on the right hand side, yes, we've got 2 oxygens, which balance with the 2 oxygens on the left hand side of the equation, but we've given ourselves 4 hydrogens on the right, and we still only have 2 on the left. That means we need to put a 2 in front of the hydrogen as well. So if we do that, we now see we have a balanced equation. 4 hydrogen atoms on the left, 4 hydrogen atoms on the right, 2 oxygens on the left, and 2 on the right as well. Okay, so that is now a balanced equation.